My name is Kyneton, the Tech Pro, and today I'm going to teach you how to perform factor analysis step by step. Actually, this is a presentation, but we are not going to be using this presentation because I can give this presentation to you to read, but I want to do the practical aspect of this presentation. So if you go all the way, you'll be able to see the step by step at this point. So I'm going to end this presentation and then I'll just take it out. Okay, so I've opened Jupyter Notebook. The data we are going to be using is the BFI data. So it's data from representing different personalities. We have, different about the feeling of others and so on and so forth. So data gathered based on personality of people. So there are different features. I think about 25 features of this data. It's called BFI, the CSV. If you look in the description box, you can find link to get this data. You can also go to this website, osf.io/CS678 and get this data set. So I'm going to first import this data set. Let's open it, look at these features, and then see how we can perform factor analysis to get the 5 or 4 factors from these 25 features. Again, please subscribe to my channel by clicking the subscribe button below and leave me a comment to let me know if this has been informative for you. If you have any recommendations, any challenges you have in your learning process, let me know as well. Alright, so let's get started. The first step is actually I'm going to be putting the steps to follow here. Import the required modules. And the first module to import, of course, is pandas. Pandas as PD. The next one is sklen. Sklen, import sklen dot datasets. Okay. Also from factor analyzer. So there is this model called factor analyzer. From factor analyzer, import factor analyzer, and finally from matplotlib.pyplot, import PLT, or import matplotlib.pyplot as PLT, because we will be doing some kind of visualization. If I run it, so we have from factor analyzer so this is gonna be from, and I think I'm typing too fast or something. All right, so let me just run it and let's see. So it's taking some time. You can see it's busy. Once you see this, the circle at this point, it says kernel busy, so just wait for some time. I think the problem, the challenge is coming from here. So I'm importing everything in sklen, the dataset. All right, so we have this problem. No module named factor analyzer. Actually, I've installed this module. So what I'm going to do, let me check whether the directory to this module is in the syspath. So let's see. So let's see sys.path. So actually, if you install a module, then those modules will be in your system, but Python is looking into certain directories for the module. So you can see that the location of this module is not in the syspath. So the modules are actually installed in my system in drive C, program files, Python 3.7, and it's live. And site packages, you can see site packages. So this is where the modules are. So I'm simply going to copy this directory and append it to the syspath. So I'm going to just say sys.path.append, and I'm going to specify this directory, and let's see. So it's fine. So at this point, if I run this code, it's going to run perfectly. Matplotlib. Let's see. So this is a typo to run. So everything went fine. And at this point, I'm going to just delete all this because they are not necessary. All right, so we've imported everything we need. And at this point, let me take the next step. Maybe we can now import the data set. So import the data sets. So the data set is in my drive D, so I'm going to call it data frame df is equal to pd dot read underscore csv and specify the location of this data set is data bfi the csv. All right, so I'd like to view this data set. View, just view the data set. So for now, I'm going to just view the heads, df.heads. That is the first 5 rows because I don't want it displaying everywhere. df.heads. So I'm going to see the first 5 rows of this data. So you can see the first 5 rows at this point, okay? You can also take a look at all the columns. So you can just say df.columns and it's going to display all the columns A0, A1, A2, A3, A4, gender and education. So this A1 to 05, they are the features we want to see if we can reduce to a fewer dimensions, all right? So the next thing we want to do is we want to drop this gender, age, and education because it is not necessary for factor analysis. So I'm going to just say df dots drop, and I'm going to specify what I want to drop: gender. I also want to drop education, and I want to drop age. All right, and I want to drop it in place. Axis is equal to 1, and in place equal to true. So just drop it and leave the data at that point. So the axis indicates a column, indicates the column, and indicates for axis 1 indicates column and 0 indicates row, right? 1 indicates column, 0 indicates row. So here we are dropping the columns, gender, age, and education. That is why we have axis 1. I'm going to just paste the explanation of all the parameters to this drop. So let me just paste it because I have it on my clipboard. All right. Okay, so I'm going to run it. So all these other columns are dropped. So if you say df.columns, you'll see that they are no longer there. So see, gender, education, and age are no longer there. All right, so I would like to kind of see the summary of these data sets. So I can just say df.info. df.info kind of summarize this data set. So kind of things that doesn't make sense. So they are actually floats, that is decimal point numbers in A1 to 05. Okay. All right. So the next thing we want to do is to now remove one of this column called unnamed. For instance, if I go to view the data df.head, you'll see that for some reason there is a column called unnamed that has been attached to that place, which I don't really know how it came about. So I'm going to kind of remove it. So to do that, I'm going to just put a comment, remove the unnamed column. So I'm going to just say df is equal to. So at this point, I'm removing I'm selecting all the columns I need. I actually could have also used in this way, but for now, let me just select the columns I need. So I want to select columns. I think let's use this since this is what we've used before. So let me just copy it. Let me copy it, and I'm going to paste it here. So in this case, we are just removing unnamed. Unnamed. Okay. So let me run it and let's see. Okay, so it doesn't work. So that unnamed is actually not the header of that column. So that column doesn't have any header. Maybe it's 0. Let's try to see if it's 0. Run. Okay, it doesn't work as well. So let's do it this way. Just say df is equal to df.iloc. So at this point, we are going to select only the columns and the rows we want. We want to select all the rows. So we put 0 to, we don't specify, sorry, we put, so let me just clarify. So to select data, you simply put a comma and to the left of the comma, you specify the rows you want to select from row 0 to the column and specify the last row. Now I don't know the last row. If you don't specify anything at the last point, it's going to select everything. In case of the columns, I'm selecting column 1. So at this point, I'm leaving out column 0, selecting column 1 to column 26. So this is from column 1, A1, to column 26, O5. That is how it is. So at this point, I'm going to run it. Alright, so if I check df.head at this time, you'll find out that that unnecessary column is gone. So we only have A1, starting from A1 at this point. Okay, now to do the big stuff now. Let's perform factor analysis. Perform factor. Well, one thing about factor analysis is you need to perform some kind of test to check if your data is suitable for factor analysis. And that test is called Bechtel's test for sphericity. So for simplicity, I'm not going to perform these tests. Let's just go ahead to perform factor analysis, okay? Alright, so I'm going to say, so I'm going to put a comment, create a factor analyzer variable and perform factor analysis. So if I'm too fast, please pause the video because I have all the steps, so you can actually copy down all the steps and follow it. Alright, so the first thing you want to do is to import factor analyzer. I think we did that from factor analyzer, import factor analyzer. Okay, so we already did that. So let's create a factor analyzer object and call it FA is equal to factor analyzer. And we need to choose number of factors we want, n factors. Let's try maybe 6 factors is okay. You can choose 3, you can choose 2, you can choose 5, and let's choose a rotation. For now, I'm not going to explain much about rotation, but rotation is necessary in factor analysis. So let's use a Varimax rotation. Alright, so I'm going to run. Alright. Now we have a factor analyzer object at this point. So we are going to now use this object to fit our data set by saying fa.fit and give your data set. So if you use fa.fit, then specify your data set. What happened? So I actually need to drop because in my data set there are some NaN that is not a number. Let me drop them. So I'm going to say df is equal to df dot drop na. I think this is the syntax. Yeah, so that is the syntax. So now it drops all the columns or all the data points that does not have a number. So that is simply what you do. It drops all the values that are not numbers. So it drops them as NA. Okay, NA means not available. All right, whether there is not a number or it doesn't have any values there, is going to drop it. Alright, so the next thing we are going to do is to now say da.fit and specify our data set. So I'm going to say df.fit df.fit and dfa.fit and specify df. Alright, so I'm going to run. Yeah, so it performed factor analysis. So what then next do we do? How do we get the loadings and the scores? Now, if you perform factor analysis, you have the loadings, you have the Eigen values, you have a whole lot of things from factor analysis. So let me get the loadings first. I'm going to say loadings is equal to fa.loadings. So these are the loadings. I'm putting it in a variable called loadings. So if I run it, can see it run. So if you, in case you want to see what is in there, you can just say loadings, and it's going to show you all the loadings. Okay, and that is not what I want to do. So we already have the loadings. The next thing is to get the eigen values. So let me just put a comment here that says get the loadings, and this one will be get the eigenvectors and eigenvalues. Okay. Alright, so to do that, simply say eigenvector and eigenvalues is equal to fa.get underscore eigenvalues. So when you use get eigenvalues, it gets both the eigenvectors and the eigenvalues, storing them in different variables. Eigenvectors for EV and eigenvalues for V. Alright. So alright, so now we have everything we need. So one thing you can do is to do a scree plot. So let's try to do a scree plot to see if 6 factors is enough, and after that we are going to display the loadings. So let's do a scree plot. Meanwhile, you can on your own you can check what the eigenvalues are and the eigenvectors. Do a scree plot. Alright, so to do that, I'm going to get the values of x. The values of x. So I'm going to call it x vals is equal to range from 1 to data frame shape, the shape 1. Now I actually would have made it easier, but shape from 1 to the last row. So shape 1 simply means the last item. Shape 1, shape 0 is a number of columns. From 1 to the end of shape 1 plus 1 because it's 0 index. Alright. Okay, so this is what we are going to use to plot. So I'm going to say plt.scatter. I'm going to say x vals and plot against the eigenvalues. That is how you get the scree plot. And you also plot a line plot, plt.plot. You now plot x vals. So that will help you visualize how the eigenvalues decrease or change with the number of components that has been added. So let me add a title, plt.title scree plot. What am I doing? And let's put the x label, plt.x label. X label. The x label should be the factors. The factors should be in the x-axis, and the y-axis should contain the eigenvalues. plt.y label eigenvalue. Okay, so I'm going to turn on grid so that I'm going to put on the grid so that we'll see how it goes. Grid. And then finally plt.show. Okay, so I'm going to run everything. Hopefully I don't have an error. So module matplotlib does not have scatter f, so I have an error, a typo here, so just remove this. Alright, so this is the scree plot we have right here. So you can see that the eigenvalues decreases all the way to about the 6th or 7th component. 1, 2, 3, 4, 5, 6. After the 6th component, then you have everything kind of straightens out. So the very first 6 components is enough to explain most part of this data. Alright, so the next thing we want to do is to let's see, I'd like to display the factors. So to display the factors, I simply say, actually the loadings, I'm going to say pd.dataframe. Actually, I displayed it before, but it seems not to make sense. Loadings. So you can see these are the loadings, but I want to display it in a data frame. So I'm going to simply say I'm going to create a data frame by saying pd.dataframe dot from records from underscore records, and I'm going to specify the loadings. At this point, I'm going to run it. Pandas does not have data frame, so I make a whole lot of typo today. So I'm going to delete. So you can see that we have 0, 1, 2, 3, 4, 5, 6 factors, and is enough to explain all the. Here we have the 6 factors at this point, and here we have the features. So I'm not going to explain and interpret this table. If you are studying statistics, so you should be able to interpret this table to know that the sizes of these loadings here tells you the weights or the importance of each of the factor against each of the feature being considered. So at this point, we've completed performing factor analysis in Python. This is a procedure. I hope I could make it simpler. I don't know who you are. I don't know if you are a beginner or you are a data scientist or you are just an enthusiast. If so, just let me know in the comment box below so that I'll know if I'm to simplify this or to break it down into maybe 3 or 4 different short videos and make it clearer for you. I'd like to thank you for viewing, and I'd also like to remind you to subscribe to my channel so that you don't miss an update. I remain Kyneton the Tech Pro, and we see you in the next machine learning and data science nuggets.